Hello everyone, I am Alok Shukla. I am an assistant professor in the Division of Mathematical and Physical Sciences at the School of Arts and Sciences at Ahmedabad University. And I'm going to talk about the course MAT 485, Introduction to Quantum Computing. This course was offered once earlier. This is the second time I'm going to offer this course. And quantum computing, I would say, is a very important discipline, emerging discipline. And it draws from, of course, mathematics, physics, and computing. This course is a major elective for BS honors in computer science. This is also a major elective for BS program in physics. Why this course? So let me say this. Quantum computing has the potential to revolutionize our lives. It has the potential to impact our lives in the same way internet did. We have, for example, these days the buzz about ChatGPT, AI, machine learning, and that's, again, a disruptive technology. I would say quantum computing is in the same league, and in the following, I will explain why. So, first of all, quantum computers will be able to solve many problems that are practically impossible for classical computers. And one example that is a very important example, in fact, is public key cryptographic algorithms. So quantum computers will be able to break that, which means all our transactions, banking transactions, or for example, you buy something on Amazon, your data is safe because it is encrypted, because classical computers cannot, break those codes fast enough for any hacker to get access to your data, private data, but quantum computers can do that. So it has, as I said, a big implication in that part. Already, world is moving towards that. In fact, Google, Microsoft, and there are many other companies like D-Wave, they are heavily investing. Even countries like the USA, China, India, as you can see here, we are investing in this technology big time, because this is going to be the technology of future, and any country that falls behind in this technological race will suffer. So this is a very important technology for future. And here we have Google, right? So Google has claim that they have obtained quantum supremacy. In fact, they have a program on a 54-qubit Sycamore processor, which was able to perform a calculation in 200 seconds, which world's most powerful supercomputer will take 10,000 years, right? So it's 10,000 years versus 200 seconds. That's the comparison. And I'll give you a flavor of it, what kind of problems a quantum computer can solve. So let's talk about the search problem, which is, it occurs in many areas in life. When you have to find a word in dictionary, for example, you search, you apply some algorithm. But here, I'll take this typical example. So let's consider you have 16 boxes, and you have white and black marbles or balls inside them. And you want to look at, so there's a box that contains a marked item. So this is the item that you want. And just for simplicity, let's say in these 16 boxes, there is just one box which contains the black there's just one box that contains the black ball, right? Now, you don't know, the boxes are numbered outside, but you cannot see what is inside unless you open the lid. In the worst case, if you have to find in which box the black ball is, you have to open all of them, right? Because the black ball might be in the last box. So in the worst case, you have to open all the 16 boxes. And in computer science, we call this algorithm, if we consider for size n, which happens to be 16 here. So for a size n problem, the complexity here is, the worst case complexity is order of n. You have to open all the n boxes in the worst case. Now the same problem, if you're doing using a quantum computer, you can do it using just square root of n calls to Oracle. Oracle is the one who is going to open the box and tell you whether there is a white ball or a black ball inside that box. So in that example, you just need 4 Oracle calls. So you just need to maybe ask the Oracle who is going to open the box and see whether the ball is white or black. You just have to do it 4 times, which is amazing. Now, this example that I just discussed is Grover's algorithm, discovered by Love Grover, an Indian American. And it's an amazing algorithm, one of the famous quantum algorithms. Now, let's talk about the course a bit. So this course will need some prerequisites, and they are either you should have taken a linear algebra course or the quantum mechanics course, quantum mechanics 1, PHY 310. So notice this is or, which means if you have taken only linear algebra, you are fine. Or if you have taken only quantum mechanics, you are fine. The course will be self-contained. It will develop all the needed quantum mechanics and the mathematical formulation. So even if you have not taken any course in quantum mechanics, I'm repeating myself here, but this is important. Even if you have not taken any course in quantum mechanics, you can still take this course. Everything that is needed will be developed within the course itself. This course will provide an introduction to the mathematical framework of quantum computing. It will discuss important quantum algorithms. Grover's search, I have already kind of given you a glimpse of it. There are other important quantum algorithms listed here, like Deuss-Jose algorithm, Bernstein-Bazirani, quantum Fourier transform, quantum phase estimation, source factoring algorithm. And this is the algorithm that can break, an application of this algorithm, source algorithm, can break public key cryptography that I mentioned earlier. And then we have HHL algorithm, and then many others. For example, we'll talk about quantum teleportation and other things in this course. Now, of course, I should also say at this point that quantum computing is an emerging field. Right now, about 400, 500 qubits, that's the limit. We cannot go more than that. And there are some skeptics who believe that this technology might not realize all the promises that it is making. But that's a separate topic altogether. In this course, you'll learn the basics of the quantum computing. You will learn programming a quantum computer. We'll be using IBM's Qiskit platform, and this will give you hands-on experience so that all those abstract concepts, or maybe quantum mechanics, the formalism and all abstract things will become more clear. And it's something like this. Let me very quickly show you. So this is the Qiskit. So there are qubits. So this line represents a qubit. Qubit is, just like in classical computing, you have bits which can be in the state either 0 or 1. In quantum computing, it could be in a superposition of both. It's like when you toss a coin, at the end of it, you get either heads or tails, But while it is in the air, you don't know. It's in a superposition of both heads and tails. Now, classically, if you think about that, it's weird because you maybe believe superposition doesn't make any sense. For example, there's a famous Schrodinger cat's experiment, a thought experiment where a cat could be dead or alive at the same time. We'll talk about all those wonderful things in this course, but right now I wanted to just show you here in this qubit, this line represents the qubit, and you can apply different gates. For example, this is the Hadamard gate, which we'll talk about in the course, and then we can see some changes in the probability. Again, we'll talk about all these things in detail. So you can do various operations. You can see what is going on in the sphere. You can, again, see, for example, if I click X here, what happens? Again, if I click X, what happens? So some changes. Right now, it might not make any sense to you, but I just wanted to show you that we'll be using lots of hands-on examples, which will clarify the theoretical concepts covered in the course so that you can understand what's going on. All right, so with this, I end my presentation. Thank you.